Oh, g'day again, champions. We're back with that Vibrolux Reverb, the beautifully clean, except for the front panel, Vibrolux Reverb 65 model. I put the link to part 1 down below for those who haven't watched it. You can go back and catch up and then come back. So I've removed all the bypass caps, removed any other components I wanted to clean up the leads on, or the eyelets. Disconnected all the primaries, replaced the switch. As we mentioned in the previous episode, the shaft of the switch had snapped off, so I managed to find a Carling replacement from Tube Amp Doctor. It did come with a replacement knob as well, because obviously that was missing because it didn't even have the shaft, but it was black only. So what do I think we might do? Although the design's a bit different, we could give them the option between the sort of correct shape black one or sort of just a generic chicken head red one. So it was previously wired for 117 volt. It was just locked into that winding because it had the old US style, Canadian style plug there, made in Canada, eh? I think I mentioned that was Euro in the last one because I was a little bit caffeine deprived probably. But what I think we'll do, since we've got a brand spanker switch, I will wire up the primaries, but I'll disconnect the center and I'll just hardwire that to the 240. So everything's still connected. Visually from the inside it looks the same, but the switch won't do anything because there'll be nothing connected to the common. That way it won't accidentally get switched and less chance for any damage there. Now, I didn't realise those leads last time I showed that had the heat shrink on them. They were the heaters for the rectifier valve, which we are going to reinstall in this for originality's sake. And the previous person who cut them really short, so we're going to have to extend those, unfortunately, which is a bit of a shame, but we'll do it as neat and tidy as we can. The rest of the wires, whoever stripped them got a little bit eager with the strippers there, so there's only about 3 strands left on some of them, so we'll have to cut it off where the jacket ends and go back another 1/4 inch to expose some fresh wire with all the strands present. Alright, so don't mind the soldering iron burn on my finger there, but you can see the primary insulation on the transformer. It's cloth on the outside, but it's actually got feels like PVC insulation on the inside, and that's the actual voltage rated stuff. Whereas throughout the rest of the amp, you've got just your single cloth wire, which is often on any side of the secondary. You can see here the heater wiring does have an inner jacket as well, so that's good. Means it's not really pushback wire, but I'm more inclined to trust it and its insulative properties. Actually, that looks just like another weaving, like fiberglass. Yeah, that's cloth as well, but it feels like it's got something impregnated in it. Anyway, enough impregnation talk. So I've gone around and cleaned the chassis and cleaned off the flux spatter from the factory, and this is the cleanest chassis I've ever seen. It's almost like a double take, like you initially think it's like a kit or a clone. It's that clean, but she's a 65er, buddy. I've just never seen a chassis that spotless before. All the flux, none of the flux stuck to it, just a plastic bristle brush, and it all just came off really easily. So yeah, it's just like one of the cleanest examples I've ever seen of a Fender Fender amp at all. And all of the resistors are within tolerance. Really weird. It mustn't have been used much at all, and it appears to have been kept in some kind of humidity regulated environment, maybe just indoors in a nice house for its whole life. It did come in a road case too, so that probably helped. But yeah, you know the stuff that usually comes across my bench, and it's pretty rare something this clean and untouched comes along. So after the last couple of amps, it's a bit of a relief to work on something that's not a complete basket case. But anyway, that's why you guys come here, isn't it? To watch me squirm with a basket case of parts. But they are out there, champions. There are clean examples of these out there still, which is fantastic. So when I'm stripping this stuff, champions, you can watch me strip for the camera. I like to start at a larger diameter first to get rid of the cloth on the outside, because if you try the final inner diameter, it's hard to get the little jaws centered. And you can end up chopping a bit of the center. So I do it in 2 stages. Get rid of the cloth first, and then go to the gauge of the actual inner wire, which is like top coat stranded. And that way you've got less of a chance of nicking it and weakening the wire right where it exits the jacket there. Tips that you can take straight to the bank and get très for. Alright, champions, so wiring up the rectifier. This is something a lot of people get wrong. It seems like the more boutique and more expensive your amp is, the more likely they are to get this problem wrong, in my experience too. You want to take your actual HT from pin 8, which is the actual cathode. Actually, it's actual. See? Actual? Fucking shut up, Brad. So a lot of the time they take it from pin 2, which means that all your HT passes through the filament before it goes to the rest of the amp. Whereas you've got a direct connection from the filament to, of course it's the filament as well, but it's also the cathode, and that's where your HT comes from. So here's the splices before soldering. I don't go crazy with the Western Union splice or the NASA splice or any of that shit. This is more than adequate, and then solder and some heat shrink over it. Now I didn't have any of the double insulated cloth wire in yellow, so I've just gone with PVC. Alright, Jimmy, so just cleaning up the cap board, just removed all the dropper resistors, all the wires from the eyelets, so we can properly clean out the eyelets, get rid of the crusty old solder and flux, and start afresh. I will be siliconing the new caps to the board as well, just to avoid any possibility of vibration, fracturing the leads or the connections or anything like that. Now again, this chassis is in remarkable condition. There's a bit of, looks like spillage on the front there, but I think that should clean off okay. But the valve sockets are just pristine. There's a light bit of residue on a couple of them from, I don't know, deoxide or something. So we'll just clean that off. But yeah, these are some of the cleanest sockets I've seen on any amp, let alone one of this vintage. They do have these sockets over here which look similar to the Mallory Bakelite ones you see quite often, which I'm not a huge fan of because the contacts are down like 4 to 5 millimeters within the body of the socket, so it only holds onto the very tip of the pin, not incredibly secure. However, I think that's done from a safety point of view, so when you're touching the socket, you're less likely to come in contact with any voltages, that kind of thing. But at any rate, they were remarkably clean too, so we'll just check that they're nice and tensioned. We can retension them with a little probe if we need to, and give them a quick clean with the mini bottle brush. You know, little pipe cleaner thingies. You get these from spray gun cleaning sets. Obviously I spray paint stuff at home, so I just buy one of them from a wholesaler every now and then. Now again, this amp must have had a really easy life, because even the droppers within tolerance still, I've not seen that even on the 70s ones. Not sure why this one in particular is, it's like it's a time machine amp. Normally these are up around 12-15k by the time you know, they make it here for repair. In the interest of originality, I know normally I'm sort of upgrading stuff for future proofing, but because this thing is so minty and everything's still in tolerance, I think I'm gonna leave these in. I'm gonna put them back in. I know, mark this day where I go for originality instead of future proofing. But you know, these will probably last a pretty long time from now on, so yeah, I think back in they go, because the amp is so close to original and they're well within tolerance. And that's the other one, even closer to the original value. Alright, so the board's clean and prepped. All the eyelets have been tinned. New link wires on the back. The old ones are a bit mangled and the lead's really thick, so it makes it difficult to get all the wires through, so I just go to like 20 gauge single core, you know, bus wire. We've prepped the leads, sort of, kinda. It's always fun doing this around a camera, but I've got the values towards the top. These are Tube Amp Doctor. I haven't had any issues at all with them so far. And just a little smear of neutral cure silicone. Sometimes I struggle to get it right in the middle. Let's try that again. Try not to make a mess. Fail miserably. Position that like so and fold the leads over. Move on to the next. So we've gone back to the stock values for this, which is 16 microfarad for everything, 475 volt. Vibrolux having a lower plate voltage. That's all you need. You don't need to smother the hell out of it. Having a lower plate voltage of the 475 volts is fine. Just like to line them up as best as we can. OCD kicking in. Alright, on to the next. So the first two are in parallel. And the reservoir cap making essentially a 32 microfarad in total. And then 16 for the screen, phase inverter and preamp nodes. As per the original circuit, because Vibroluxes are meant to be a little bit squishy. Right, so that one's already got a hole there which just clears the screw in the chassis. I'll just try and position the silicon away from that a little bit so it doesn't all ooze through the hole. Oakley Dokerino. So obviously you've got the choke. These are both the B plus node in parallel. And then you've got the choke between these two positives. And then between there and there you've got 10k, 10k as per the stock circuit. Alright, so now particularly with using the stock resistors with their real thick leads, you might struggle to get a wire down in there. So I just get these like little optometrists screwdrivers, you know, for glasses, and just find one about, I don't know, 1.5 millimeters, and just force those leads apart a little bit, and that just allows a little opening there to get the wire down through. Sort of straightens the leads and just shoves them all into the corner of the hole. Corner of the hole. Trying to corner a circle again. Good on you, Brad. So now we can just put a dab of solder on there to hold everything in place, get it back in, and then get those wires through. It is pretty amazing how much smaller modern caps are, and these aren't even like the most advanced ones going around. If you go like real modern high quality radials, even smaller than this. It's crazy. There you go, champions, ready to put the doghouse on. What do you reckon? How's it look? Let me know in the comments, like all the other YouTubers say. Alright, champions, it's time to chuck the doghouse on. When we flip this amp back over, we'll not be flipping it back over until we start testing it. So may as well populate the valves and flip it over, so when we're finished with the guts, we can fire it up and have a listen, do some testing. So before I do that, just looking at the valves, most are in really good condition, but some have that sort of black tarnishing on the legs. So what I like to do is wrap up a bit of Scotch-Brite into a little tampon like that, and just get your end in. Just gently give it a bit of a turn. Try not to bend the pins in the process, but just give it a little bit of a twist to open up the inside of the pins, and then do the same from the outside with just a little bit of Scotch-Brite. Now, nothing too aggressive, just to expose the metal through that tarnishing. If it takes more than just a light rub, you probably need to replace the valve. It's probably suffered some kind of caustic cleaning fluid, as people I want to do. And just clean the dust off, and in she goes. After cleaning the sockets, of course, which I forgot to film. And we've got three 7025s made in the USA. I think they're Sylvanias. They could very well be the original preamp valves too. So hopefully they're not microphonic and behave themselves. So I'll stick the three 7025s we've got in the two preamp stages and the reverb recovery stage. We've got a 12AX7 Mallard there too, so I'll pop that in the tremolo position, and we'll just see what the quietest combination is. If we have to do a bit of tube rolling, as they call it, then so be it. Now, you've probably seen on Fender amps in particular, there tends to be yellowing around the output valves wherever it's really hot, and I did clean a bit off. This is pretty clean chassis, but there was a bit of yellowing in that area, and what that is back in the day when everyone used to smoke in the bars and whatever, the air rises around the hot valves, around the rectifier and the output valves in particular, because they're the hottest, and that motion of the air constantly rising, because remember this is upside down, draws all the smoke residue and it deposits around the hot valves, because as the upward flow of the air is happening, all the tobacco residue sticks to the chassis in that area. Interestingly, even though the rectifier tends to be the hottest valve out of the three, there was mainly smoke residue in this area, but none around the rectifier, or very little compared to this area. So I'm thinking that that modification to the solid state rectifier happened pretty early in the amp's life, or at least before it did the majority of its work, and I'm guessing sometime before the 90s, when smoking became more or less outlawed in every venue in Australia. So I'm thinking for the majority of this amp's working hours, it had those rectifiers in place. This is all just speculation, but still interesting nonetheless. Well, to me anyway, but I'm a weirdo. Now, although champions, I've been having problems with Tube Amp Doctor, particularly the red bass series, running away bias and stuff. We've got a bit of a love-hate relationship at the moment. They've replaced some of them, but yeah, eventually they're all going to have issues, I think. But I haven't had any issues at all with their rectifier valves. So this is stock I had before I started having issues with them. However, in my own amps and in some test amps that I've got here, I've been running their rectifiers solid and torturing the shit out of them, and they haven't missed a beat. So I'm confident to use this in this amp. However, just the general practice with Tube Amp Doctor, I think I'm going to be moving to JJ's for pretty much everything other than 6V6s from now on. Maybe the 6L6s, something about the 6L6s, 6V6s, JJ's just can't seem to get the microphonics right. They always end up having microphonic issues, so I'll be using electro harmonics, or I don't know, it could change next week. It's such a whack-a-mole thing, but that's why I'm here, to be your heat shield. I'm the one that finds out what works and what doesn't, and you're the one that just gets to play the amp. Isn't that a good little arrangement? So we'll pop this one in and monitor it for a good couple of hours and just make sure there's no issues. Okay, something funny going on here. I can't get that rectifier valve in all the way. It's sitting up about probably about 2 millimeters or more. So I think something's wrong with that, one of those pins in that socket, so I'll just have a close look. Yeah, you probably can't make it out on the camera, but the bloke who did the diode rectifiers down there put so much solder on the pin that it's actually run down into the socket and collected in the bottom of the pin receiver, of whatever you call it. Bottom of the socket, there's a blob of solder, so might have to shove some wick down there, or maybe have a look, see if I've got one of those narrow desoldering pins. But I don't know if we'll be able to access that from the other side. Maybe if I work on it upside down, might be able to bleed that solder back down onto the eyelet and suck it up. Yeah, there's always something, eh? Alright, so I managed to heat it with the soldering iron with a long tip in the pin hole at the top, as well as the desolder gun down the bottom. Heated up the whole pin, eventually a wick down to the bottom, managed to remove all the solder, and then clean the flux and stuff off with a little cleaning brush, and now you can see she's all the way home. So you gotta keep an eye out for these kind of things. They can trip you up. That rectifier valve would have just fallen out with a bit of vibration, even with the bare traps. Original ground was mounted to the transformer hardware. I don't like that, and there's also no caps nut there, so there's nothing, and that's not a tooth washer, so there's nothing really holding that, locking that bolt in place. I don't want any grounds connected to the transformer hardware, because it can potentially loosen over time, and you certainly don't want the safety earth loosening. Now, generally what you can do is solder directly to the chassis. Just clear a little spot with some Scotch-Brite, prep it, and solder to that, but I don't like soldering to such a clean chassis. Unfortunately for us, down here, normally you'd have the cap, the def cap wire passing through there, and they just solder it to the chassis in that area. This is the ground switch. We can use that with either Kep's nut or, you know, a nylock nut and a tooth washer, toothed eyelet, and we can make that our grounding point. Now, generally you want your ground connection like as close as possible to where the cable entry is, but we're talking like 150 mil, maybe 120 mil. So I think we're splitting hairs a bit there, and that way we don't have to modify the chassis, which is preferred with 65 Vibrolux reverb. Alright champions, just tightening up the hardware. It was all pretty good, but just making sure it's all nipped up. A tiny bit of, start off with just water on a rag and see if the spillage on the front was soluble in just water. because the less chemicals you use the better. And that's cleaned it off pretty well. So I'll just get in there with a bristle brush, pig bristle, similar type that I use for cleaning PCBs and stuff, and just clean out the shmoo next to the screws and the nuts and stuff. Get in the bright switch there. It looks like brand new, this thing, once we've given it a clean. This is all the stuff that a lot of the other techs don't even think about doing, which is probably why they own houses and stuff and I don't. I do hear from fellow techs I'm a little bit pedantic when it comes to cleaning and stuff, but to me the finished product is partially how it looks as well as how it functions. So if underneath there is a diamond, let's polish it until we can show it to the world or something. I don't know, I'm talking shit. Moving on. Now I try to avoid on the vintage stuff cleaning the knobs even in water, because literally water will make the white paint in the letter recesses run. So if we can avoid it, we'll just keep it dry and just get the dust out of the flutes with a dry brush, and just the little bit of dirt and finger cheese that's inevitable. Kind of gross when you think about it, but comparatively this is very clean. Should see some of them I get in here. So you don't want your knob bottomed out. Now in this situation anyway, the bedroom's a different matter, but you can see there it's scratched a sort of semicircle on the faceplate there, and it can get real bad if they're like that its whole life. So we want to intentionally space the knob, I don't know, about 1.5 mm off the faceplate before we tighten up the set screw. And to do that, I just like to put a ruler behind it, and you don't want them too tight against that either, because if you're not careful you could scratch it when you go to remove it. Alright, so there we are with our mains wiring sorted. We've got the active coming into the fuse tip, the fuse ring going to the switch going to the black on the transformer, the common. Now over here, just to make things simple, I've sort of, because the mains wire was a little bit too thick to get through the eyelet of the switch, and you can't really drill them out because you'll mangle the contact once the drill tries to get through. Ask me how I know. I've tried it before, champions. So I've just attached the neutral to the 240 volt tap, just not touching the switch at all, just spliced beside it with 2 layers of heat shrink on there. Someone had melted a bit of the 240 volt wire, so I just extended the heat shrink further up a bit, so it's about 1.5 inches long. So you've got all the switch contacts of the voltage selector switch connected to the different voltage taps, but nothing connected to the pole itself. So they're essentially isolated, and we've hardwired it to 240 volts. And we've done our best to keep the mains wiring away from the secondary wiring, and we've done our best to keep the mains wiring, the primary, away from the secondaries, not making contact anywhere. That is, I think it's a CE certification requirement. In this case, we're just doing it to be as close as we can to ideal, but you know, grandfather clause, champion, grandfather clause. So I've reflowed the grounds, and I have cleaned off the flux in that area, so everything's looking nice and spiffy. I've left the heater center tap attached, so I haven't done an artificially balanced heater. We'll see how we go noise wise. It's sort of a balance of performance and originality in this one, and being that this amp doesn't have a cathode follower, it's not as critical, it's not as scary to think about like a HT to heater short, because that's more likely in a cathode follower equipped amp. And at the end of the day, it's been alright since 1965, so it's probably fine. We'll just see how we go noise wise, how balanced those heater windings are, and if we need to, we can artificially balance that and lift that center tap. Alright, so let's fire this thing up and give it a test, and do some sound samples after that, whether or not I include them. I don't know, you know what a Vibrolux sounds like, but you know, if I'm particularly enamored with this, I might do some sound samples as well. Alright, I can't remember if I showed this in the first episode or not, but I'll tell you again. The beautiful Philips 6L6s heavily out of balance, so ratio about 3:1 in idle current there. So I did quote for a new set of mullards, so I'll install them and see how she balances up. I should mention that when you see a big imbalance like this, it's good to check the voltage on the grids just to make sure there's not a leaky coupling cap or something. And we've got within about 5 millivolts on both sides balanced. Alright champions, we've got the new Mullards in there, and she's balancing up nicely. Bear in mind there's 72 ohms on that side and 81 ohms on that side, so that's why the voltages are a bit different. That's the DC drop across the primary, the output transformer in quiescent state. So that's bang on 60%. Unfortunately, the old Philips can go to the museum, and no good if you want hum rejection and performance. And when one valve goes way out of range, chances are it's on the verge of failure anyway, so a bit more peace of mind there. So I just had a play, and god damn, this is the best sounding Fender amp I think I've ever played. I've not seen many Vibroluxes, and when I have, they've been reissues, and mainly the issue with them was the heater connections burning and the fuse on the PCB catching fire. Not quite, but you know, burning the PCB. So that's the biggest issue with them, other than the IC brand caps, but they're just not that common, even the reissue Vibroluxes. So I haven't really sort of played with one much before, but the lower plate voltages and the lower filtering, the less filtering, makes it a really nice, I don't know how to describe it, chewy? I think Frankie from FGR says chewy quite a bit. So I better watch myself, or he might give me a copyright claim. Isn't that right, Frankie? So everything's pretty awesome, but one last remaining issue. Take it out standby. Got some ambient noise here from the lighting above. That'll be fine when it's shielded in the chassis, but listen to the noise floor there. And when I push this contact, it goes away. So that noise is coming from the fact, that's not even self noise, that's coming from the fact that the input's not grounded. That's the self noise, almost nothing. The background noise is, the music in the background is probably louder. But we can clean and retension these. Now there is a bit of a trick to it. You can't just push the contacts, they sort of spring back and make the problem worse. So if you're going to do it, I'll show you how to do it. So in addition to cleaning the contacts, check that doesn't work at first. But what usually happens is the inner shunt sort of loses its spring over time. So I put like a 1/4 inch or 6 mil piece of round bar in there, and then you want to bend it at the root of that contact, not at the tip, because it'll just spring back and make the problem worse. So I get a flat blade screwdriver in there after that, and then lever against that bit of bar, and just get a bit more angle on that contact. And now, combined with cleaning, you can see it's actually taken up about 1 millimeter before it stops moving. So that should have sorted the problem now. But if you were to just bend that in situ, like just try and shove it that way, it's going to bend that one as well, and it's also going to spring back, and they'll bend by the same amount, but you'll still have that opening between them. So that is the way to do it. Take that one to the bank and bloody cash it in, champion. Well, champions, as soon as I hit record every time. Well, champions, I'm pretty chuffed with this one, and if I see a Vibrolux going for a reasonable price, I think I'll jump on it, because this thing sounds awesome, and I'm pretty confident I could make any other sound awesome too. I think it mostly comes down to the voltages in the thing compared to the twins and the higher powered models, and just having a bit more punch and a little bit more push than the Deluxe Reverb and the Princeton. So it's kind of the sweet spot. Good for gigging if you've got a slightly heavier hitting band, right in that sort of mid-range, but not ear bleedingly loud before it starts to break up nicely like you get with a twin. And you can just ride that volume control on your guitar just like your granddaddy intended, to control the amount of bite, and it's just heaven when you're in that creamy little middle zone. And the Vibrolux has just the right amount of output power and right amount of squeeze to really respond well to that style of playing. I think it comes down to the minimal filtering and the lower plate voltages, or the lower HT throughout the entire amp, really gives it a nice, beautiful breakup. but you can still get that Fender chime and the sparkle if you want it. Alright, so just giving the cab a clean up, checking out the tank, Gibbs reverb tank, giving the tank bag a clean, already done that. Just checking the connectors, checking all the baffle fixings are okay. This is just shit I do on every single amp that comes in. Combo anyway, obviously. Redid the solder connections on the speaker tabs, cleaned a bit of corrosion off there. The previous person that, I think these speakers have been replaced, the previous person that put them in, the solder didn't really wet to the contacts, it was sort of balled up, and that could lead to a lack of continuity. So it's got a nice fillet there, a nice flow after a little bit of Scotch-Brite. Just be careful not to get the dust down in the speaker. So time to get this thing back together and do a quick play. Now call me weird, but another thing that really irks me is when you pull out a reverb tank and there's like 500 holes in this area from the previous techs removing the tank and not realigning the hole with the original one. Call me crazy, but I like to not make extra holes if I can avoid it. I don't want to turn a cabinet into Swiss cheese. Oh look, cabinet built by Slim. I didn't know they signed their name on them. April 63 maybe? 463? I've checked the foot switch out and all is well. Thanks for those that commented. Apparently the black paint was the original for that period and they went silver later on. I thought it was the other way around, but anyway. I know they had some black ones in the 90s. So all is well on both ends, and actually incredibly the jacket of the cable is still somewhat supple. I don't know if maybe it was a change to the material on the 70s ones, but they're often so stiff that they're just unusable. You got to chop them off and put new cable on them, or just get a replacement switch. I mean, you know, it's 70 bucks or something. Well, champions, I've got to say it's been an honour to work on this one, particularly when it's been so well taken care of. It really warms my heart to see when people respect their old amps. And it's going to live to battle on many more decades, probably outlive me. So thanks for watching, legends. Don't forget to give us a like, you know, subscribe, blah, 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 blah. Old YouTuber influencer bullshit. Gotta say it, it does help. And I'll see you on the next one. Take it squeezy.